going to talk about families of functions. Now, I'm being very serious when I say we use this all the time. Like, this comes up almost every single day in pre-calc, and it comes up in AP Calculus all the time, too. So this is one of those lessons that I want to make sure you guys understand fully, because we're going to be using it a lot, okay? All right, it doesn't go away. So if I'm talking about families of functions, what is supposed to be the main source of a family? The mom and dad, I agree. Well, just like in families, a family of functions have a mom and dad, or what we call a parent function. A parent function is the most basic form of the function. All right. So, for example, the most basic form of a line is simply x. That's a parent function. That's the most basic form. Or the most basic form of a quadratic, or the parent function of a quadratic, is simply x squared. The most basic form. Now, we can take these basic forms and we create additional things from that, just like parents do, right? We can create other functions from the most basic form. And when we create these other functions, this is what we call transformations or translations. Now, those words should sound familiar. Yes, they do. Somebody tell me some examples of transformations. Okay, so give me an example of translation. Okay, it moves, exactly, right? Transformations and translations. That's where something, Kaylee, are you with us? Uh-huh. Doesn't appear currently that you are, so join me. All right. So transformations and translations are where you can actually move something, and a lot of times in geometry you might have moved a triangle, right, or a square. You might have moved it right, left, up, down, okay? Sometimes you flipped it over or you reflected it, correct? Okay. There was also when you stretched it, it became what? Yes, it was a dilation, right, or you shrunk it. We're going to do the same thing. That's how a parent function gets the additional functions that go with it. It has those transformations or translations, okay? So, and it is done the same way to all parent functions, whether it's f of x equals x, f of x equals x squared, f of x equals x to the third. No matter what, the same thing happens to all of them, all right? So that's what we're going to talk about. Yeah, right? So first thing we're going to talk about is when we are translating up or down. In functions, the letter we use to represent this is a k, a lowercase k, all right? In our function, whatever the function is, so I'm just going to call my parent function f of x. If it is moving up, then it's going to have a plus k on the very end of your function. This says we go up, k units. K units. If it has your function and then minus a k, it goes down k units. That makes sense, right? Okay. So the first few you have in your homework all have to do with moving it up and down with that value of k at the end. All right, so for example, let's say, here's example number 1. Your parent function is f of x equals x. I'm just going to do a normal x. And I want to know, describe and graph the translation of f of x equals x plus 4. So first of all, when I have x, or when I have plus 4 at the end, what does that mean we're going to be doing? Yes, we are going up 4 units. Okay? Now I picked a line as my parent function so you guys can actually see this happen, for example. So if I'm going to graph this, first of all, if I were to graph f of x equals x, that's just a diagonal line through the what? The origin, right? It goes up and over 1, so it's a perfect diagonal line right through the origin. Okay. Now if I were to graph x plus 4, where do I start? Yeah, 1, 2, 3, 4. I would start there, and then technically I would do my slope, which is up and over 1. So what do you notice about that line? It has moved up 4 units, right? Right? That's all it was. So you guys have actually been doing families of function for years. We just said you were graphing in slope-intercept form. You've really been doing it whole time. Okay? I know. We're so mean. I don't know. All right. Here's example number 2. So this time, instead of me graphing, I want you to make a table of values for, whoops, f of x, translating down 2. All right, and in my table, I'm just going to do a table. So here's my table. Let's say I have x and I have f of x, because f of x just means y, right? And let's say in my table I have, I don't know, -2, 0, 2, and 5. And over here, maybe I have 3, 7, 10, and 15. Sure. All right. So I want to do a new table that says I have gone down 2. So I have my x and I have my f of x. If I am going down 2, what is it impacting, x or y? Think about a graph. If I'm moving something down, it's affecting y. Exactly. So that means that all of my x values are going to stay the same. Okay? And if I'm going down 2, what do you think I'm doing to all those y values? Minusing 2. So here if I have 3 in my new table, it becomes 1. If I have 7 in my new table, it becomes 5. Yeah, if I had 10, it becomes 8. And if I had 15, it becomes 13. Yeah. Yeah, seriously. Example number 3. You guys trust me. Example number 3. On example number 3, let's say, write a vertical, I'm writing the words differently, vertical translation of y equals f of x for, let's say, 7 units up. So if I'm going 7 units up, what am I going to do to the end of my function? Well, I'm going to move it up, but how do I move it up? What am I doing to my equation? You add 7. So my answer to this is simply y equals f of x, because that's my parent function, plus 7. Exactly. That's it. Okay, are we still doing all right? Well, I'm only up to number 16 so far, so how are we doing? Right? Okay. So we just talked about going up and down, right? We have to talk about going right and left. Yeah, side to side. So, okay, when we are moving side to side, it impacts x, which means anytime we are moving side to side, if we move right or left, it impacts the x value, which means when we are writing it, we have to put it in a parenthesis with x. So for example, if I have my function and I have x and I put minus, and for moving right and left, we use the variable h, just so you know. So I'm going to put h here. Now think about point slope form that we just did, right? When we put a value in, that h would be positive. This means that we are going to the right h units. It's kind of like point slope form, how it looks opposite when you put it in, right? The y minus y1. So this is x minus the h. So if h is positive, this is going to the right. It falls in there. If I have f of x plus h, that's going to the left h units. Now another way you can think about this to make sure you can tell which way it's moving is you can take what's inside that parenthesis and set it equal to 0 and solve it. And that'll tell you also. So if I had, let's say, f of x minus 4, this would tell me that I am going to the right 4 units. If I had f of x plus 3, that would be going to the left 3 units. Okay, we still doing good? All right. So then, let's try this. Example number 4. For example number 4, identify the horizontal translation for the parent function y equals x squared. All right. So if I have y equals x plus 5 squared, because it's in with x, it's going to tell us whether we're going right or left. Right? In this case, this would be left 5. So some students like to think of it, it's always opposite, right? It's like x minus a negative 5. Some students, as I said, like to take x plus 5 and set it equal to 0. That tells you you're going to negative 5. So it's whatever makes the most sense to you, right, what clicks. How about this one? What if I said y equals x minus 2 squared? How's that one moving? Right 2. Awesome. All right. So now this is an extra little bonus. I'm going to kind of do this for a second. What? No, don't say uh-oh. What if I said y equals x minus 4 squared plus 3? So start here. What is it telling me we're doing here? Right 4. Right 4. And what did you say, Logan? Up 3. Exactly. Up 3. It's easy, right? Okay. How we doing? We're doing okay? Yes, exactly. Very good. All right. Okay, I don't want you guys to panic about the time. I still got more to talk about, but we're probably not going to do the homework this weekend, okay? Let's do it for Monday. All right, so anyway, let's continue. Well, that's why I get to talk again a little bit. All right. So, in our let's try something like this. What if I wanted you to, I don't know, what is this, example 5? All right. Write a rule. A rule for f of x equals x squared to move. How about left 9? All right, so we have f of x equals. Now, in with x, so it's really going to be a parenthesis and then the squared. I have to have my x plus 9. Very good. That is x minus h. And since h is left 9 or negative 9, x minus a negative 9 is x plus 9. Okay? So far, you guys, we are all the way through 21 in this assignment. We are doing so good. How about this one? We'll stop after this one, and then we'll finish the rest on Monday. Okay? You guys good with that? All right. So, on this one, let's say I want you to make a table of values. Table of values that move 4 units left and graph. So this time, however, instead of giving you a table to start with, I'm actually going to give you a graph. So let's say we have, here's a point, and here's a point. Go over here to 4, 2, and then we'll go back down here. So I'm going to connect my dots so you guys can kind of see. I'm making like a little, I don't know, trapezoidal something. Kind of. All right. So we can do this one of 2 ways. We can first move it 4 and then write our table. Or we can look at what we have, subtract 4 because we're going to the left, and write our table. I think sometimes it's easier if we go ahead and move all of our dots and then just rewrite our table. So if we translate the first dot 4 left, it would go 1, 2, 3, 4, and I'm going to put a dot right here. So in my table, my first dot would be at -3, 0, exactly. Okay? I'm going to translate this one to the left 4. So 1, 2, 3, 4. So that point is at -2, 1. Next one, I'm going to move this point to the left 4. 1, 2, 3, 4. So that point is at 0, 2, thank you. And the last point, if I move to the left 4, 1, 2, 3, 4. 1, 0. Okay. And now let's go ahead and connect our dots and see if our shape looks pretty close to the same. All right. Hopefully it looks close to the same. Huh? Yeah. Good. And that's what it's supposed to look like. So we can actually use a table to move it from side to side as well, right? So the only things we haven't talked about yet is reflecting that function and, of course, stretching it, making it bigger, or dilation, or making it smaller. So those are the 3 things we're going to add on to this on Monday. Okay? So, yes, you do not.